large-scale destructive attacks on big machinery is not something that I would consider a credible attack.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions, who's going to introduce the subject and guest of our show today. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Kenneth Titlestad. He is the Chief Commercial Officer at Omny, and he's also the chair of the Norwegian International Electrotechnical Committee subgroup working on 62443. So this is the Norwegian delegation to the IEC that produces the widely used IEC 62443 standard. We're going to be talking about credible threats. What should we be planning for security-wise? And by the way, I had opportunity to be in Norway, and I visited Kenneth at the Omny head office, where they have a lovely recording studio. So we recorded this face-to-face in their studio in their head office.
Then let's get right into your conversation with Kenneth.
Hello, Kenneth, and welcome to the podcast. Before we get started, can you tell our listeners, give us a bit of information about your background, about what you've been up to, and the good work that you're doing here at Omny Security?
Thank you so much, Andrew, and welcome to Norway and our office. I'm so glad to have you visiting us. So my name is Kenneth Titlestad, and I'm working as a Chief Commercial Officer in Omny. And I've just started as a commercial officer here in Omny. I went over from Soprasteria, where I was heading up OT cybersecurity. I've been doing that for 6 years. Before that, I was working in Equinor, also working on OT cybersecurity. So I've been working in the field now for almost 15 years. And also for the last 5 or 6 years, I've been chairman for the Norwegian Electrotechnical Committee, the group that is handling IEC 62443. So I've been diving deep into OT cybersecurity now for quite many years. At Omny, we are developing a software platform for handling cybersecurity and security for critical infrastructure. It contains a security knowledge graph and AI that provides actionable insights into security for critical infrastructure. So it's about IT, OT, and physical infrastructure.
Our topic today is credibility. Now, this is talking about risk. A lot of people think risk is boring. Okay, a lot of people, when they enter the industrial security space, they want to know about attacks. They want to know about the technical bits and bytes. You tell me that you got interested in risk a very long time ago. Can you talk about that? Where did that come from?
Absolutely. I'm not sure if when I considered it as a risk or as a field of expertise. So when I was just a small boy, actually, my dad, he worked as a control room technician offshore in ConocoPhillips, or back then it was called Phillips. So when I was only 3 years old in 1977, he was working at the Bravo offshore oil and gas platform. And I don't remember this, of course, back then, but it was always a topic around the dinner table at my home, where he talked about how it was working in the oil and gas business. So in 1977, he was on his way out to the platform when the big Bravo blowout happened. He was not actually, he hadn't arrived at the platform, but he was on his way out there. So it really was a big topic around the dinner table all the time about safety risks involved in oil and gas. So I was always listening with my small ears back then, being a bit fascinated about this world. I didn't see the real danger in it, but I was trying to picture it in my mind, what it was to actually work on in these kind of environments. So I was kind of primed back when I was just a small boy, And later on, when I moved into I was more into computers, so I did a lot of gaming and programming on Commodore 64. And I started to work in Equinor on the IT side, but I was still fascinated about the core business being oil and gas and production and exploration. So when I actually got my first trip offshore, I kind of felt that the circle was closed, and I saw the big world, the industrial world that my dad had been talking about for several years, and the risk perspectives also kicked in. The first thing you meet when you step on board such a platform is the HSE focus. A lot of focus on HSE, and it's for a reason. And I fully got to understand that first when I actually came on board such a facility. I understood why it's so important, because it can be really dangerous if you don't have control over what you're doing. So that's when I actually saw the big scale of risk as a perspective.
Yeah, offshore platforms are intense. I've never set foot on one myself, but I've heard the stories. It's
Absolutely.
Quite the environment.
Yeah.
And this is, we're talking about industrial cybersecurity. So, offshore platforms are intense in terms of physical risk. Can you talk about cyber risk?
Yeah, absolutely. It's an emerging topic. So when I was working in Statoil, when it was called Statoil, now it's Equinor, we started to look into that area around 2010, 2011. I still remember the day when people came charging into the meeting room and they started talking about the news of Stuxnet. So that was, I think we got to hear about it in 2010. I was working on the IT side, and I was responsible for large parts of our Windows infrastructure in the company. And I started to look into what is SCADA things. What is it? I didn't know about PLCs. I had never seen a PLC. I didn't know that there was actually other kind of digital equipment operating critical infrastructure. So with Stuxnet, I started to dive into the landscape of OT cybersecurity. And also as a company, we started a big journey back then on really making OT much more cybersecure. And Stuxnet was kind of a kickstart for it.
Andrew, it feels like maybe there are certain kinds of seminal cybersecurity incidents in the OT world. We reference often the 2007 Aurora test, maybe, Triton and Destroyer, but Stuxnet is that foundational thing that, set the timeline for everybody, right?
Indeed. And, I was active in the space. I was leading the team at Industrial Defender, building the world's first industrial SIEM at the time. So Stuxnet was big news. I did a lot of work on Stuxnet. I had a blog at the time. Every time I learned something new about it because somebody had published a report, somebody had published another blog, I'd done a little research on my own. I'd published this. I published a paper on how Stuxnet spread. Because analysis had been done of the artifact, the malware, but it had been done by IT people at Symantec, at I think ESET. A bunch of people had analyzed the malware, and that's work I couldn't do. I'm not a reverse analyst. But I sat down with Joel Langill, I sat down with Eric Byers, and we investigated the impact that Stuxnet would have in a network. What would happen if you let this thing loose in a network, given our understanding of the Siemens systems? Joel was an expert on the Siemens systems. Eric and I were sort of more expert, more generally on firewalls and industrial systems. So we all contributed to this paper and, said, here's what happens if you let loose Stuxnet into an industrial network. And, in hindsight, I have to wonder if we didn't do, more damage than good, because a lot of people learned stuff about Stuxnet, but there was only one outfit that benefited, and that was Iran's nuclear weapons program. And it was the only, site in the world that was physically impacted. So I regret some of the stuff that I published about Stuxnet.
Do you recall if that research got traction, whether it might have gotten over there, or is there no way to tell?
I have no way to tell. I do recall a conversation, sometime later, because I'm a Canadian. I work with the Canadian authorities. I remember a conversation with Canadian intelligence services, and I remember, asking them, I've stopped, at one point when I figured out that there's only one place in the world that's physically benefiting from my research, I stopped publishing anything about Stuxnet. And I remember sometime after that talking to Canadian intelligence saying, I've stopped publishing anything about Stuxnet. You don't have to tell me nothing. In the future, if you ever see me putting out information that's helping our enemies, tap me on the shoulder, would you, and tell me, shut up, Ginter. You're doing more harm than good. And I will shut up. So, yeah, I look back on Stuxnet with mixed emotions. It was a wake-up call for the industry. A lot of people learned about cybersecurity because of Stuxnet, but who benefited because of all that research? Okay, so that's, Stuxnet is how a lot of people got started in the OT space. It was the big news
Yeah, absolutely.
15 years ago. Can I ask you, let's talk about industrial security and the work you're doing. The work you've been doing. Stuxnet is where it got started. Where have you wound up? What are you up to today?
Yeah, it's as you say, it's 15 years, and for me, I think it's been a very interesting journey. So, but back in 2010, when Stuxnet hit the news, I wasn't immediately diving into OT cybersecurity full time. I was working on the IT side, trying to secure Windows environment in a large oil and gas company. But after a while, I moved more and more over to OT cybersecurity, and I had my first trip offshore to an oil and gas platform. I think that first trip was in 2013, so actually 3 years after the Stuxnet. But then I was going out just to do some troubleshooting on a firewall. So, more and more I was moving into OT cybersecurity, and at the end I moved over to Soprasteria. I think it was in 2017, and at the end I was really working hard on finding really proper solutions for OT cybersecurity. When potential nation states are targeting you, what do you then do if you must sort of have the mindset of assume breach? And these kind of systems with the PLCs and all, they are really, really vulnerable. What do you do when you are being targeted? So then I started to look into, I heard rumors that there could be something that was non-hackable. So I started investigating into unidirectional data diodes, was exposed to Waterfall. That was one of the first examples of where I heard about non-hackable stuff. So, and also I got to hear about the crown jewel analysis, cyber-informed engineering. Back then it was consequence-driven cyber-informed engineering. But those kind of topics really sparked an extra interest for me, because then I saw on some attack vectors, on some of the risks, I saw actually a solution that could remove the risk instead of just mitigating it.
So your first sort of foray, everyone was interested in Stuxnet, but you started working on the problem. You said with a firewall, and to a degree that makes sense. I mean, the firewall, the IT/OT firewall, is often the boundary between the engineering discipline on the platform in the industrial process and the IT discipline, where information is the asset that needs to be protected. And so that boundary is something that both the engineers and the IT folk care about. So that kind of makes sense. I'm curious. You got out to the platform. You were tasked with the firewall. What did you find there?
Yeah, it was actually kind of a long-lasting ticket we had in our system. There was a firewall between IT and OT that was noisy, so it was creating a lot of events and alerts on traffic that it shouldn't have. So I was tasked to go out there and try to troubleshoot this. We absolutely didn't think that it was a cyber attack or kind of evil intent, but it was an incorrectly configured firewall rule. But when I got out there, I could see that it was just incorrectly configured firewall rule. It was not anything dangerous or a cyber attack involved. But I also got to think of a scenario where if it had actually been a cyber attack and one that created so much noise as well on a security boundary, a security component sitting on the outskirts of OT, shouldn't the OT environment do something to sort of shut down or go into a more fail-safe situation? So I got kind of interested in actually the instrumentation behind your security components on the outskirts of OT. So that's a topic I continued to explore for several years, having in the back of my mind cyber-informed engineering, non-hackable approaches, unidirectional mechanisms. And on S4 last year, I talked about the safety instrumented system, because safety has always been a particular interest of mine. So I talked about the cyber-informed safety instrumented system. Shouldn't the safety instrumented system, at some point when you're under an attack, shouldn't the sort of the big brain in the room, shouldn't that actually take an action? An instrumented, automated action, and going into a more, not necessarily a fail-safe only, but a more fail over to a more safe and secure situation.
So that makes sense in theory. I mean, if the firewall was saying, help, help, I'm under attack over and over again, should some action not have taken place on the OT side? But let me ask you this, it was a false positive.
Yes.
It would have shut down the platform, a very expensive platform, unnecessarily. Can we detect cyber attacks reliably enough to prevent this kind of unnecessary shutdown? If we do shut down whenever there's a bunch of alarms, is that not a new sort of denial of service vulnerability? The bad guys don't even need to get into OT. They just need to launch a few packets. The firewall generates some alarms and the whole thing shuts down without them even bothering to break into OT. Is that really the right way forward?
No, I totally agree. It's not a good approach going forward. But at the same time, I think to shut down one too many times is better than not actually doing it. So we should be kind of overreacting and going into fail-safe situation, and it could cause unnecessary downtime, and it's a vulnerability on the production side. But I think it's much more dangerous with the false negatives, where we actually don't see any attacks, but it's actually happening. So false positive, we need to reduce them, but it's much more important to actually reduce the false negatives.
In 2024, there were 76 cyber attacks that caused physical consequences at over 1,000 sites in heavy industry and critical industrial infrastructures. Transportation and discrete manufacturing were most impacted, and we saw impacts on water and power utilities, pharmaceuticals, metals and mining, food and beverages, and others. All these details and more are in the latest Waterfall ICS Drive OT Cyber Threat Report. You can find it at https://waterfall-security.com/2025-threat-report. We hope you find the material useful.
So Nate, just listening to the recording here, I mean, this is not something I discussed with Kenneth, but we were talking about automatic action when we discover that an attack might be in progress. For example, because there's a lot of alarms coming out of the firewall. You know, he agreed with me that shutting down the platform was probably an overreaction because, that introduces a new attack vector. The bad guys just need to send a few packets against the firewall, generate a few alarms, and the whole platform shuts down. I agreed with him that something should be done, but we didn't really figure out what. Here's an idea in hindsight. A number of jurisdictions are introducing what they call islanding rules, meaning if IT is compromised, you need to, basically, power off the IT/OT firewall. Nothing gets through into OT anymore for the duration of the emergency. So you have the ability to shut off all communications into OT. This is part of, the regulation says you must be able to island. So now you have that capability. I wonder if it isn't reasonable to trigger islanding when you discover, automatically discover a whole bunch of alarms coming out of anything. Because the modern attack pattern, most of modern day attacks are not like Stuxnet, where you let it loose and it does its thing. Most of modern day attacks have remote control from the internet. And if you island, if you break the connection between IT and OT, if there was an attack in the OT network, the bad guys can no longer control it. They can no longer send commands. So, and this is not new. The term islanding is a little bit new. The concept of sort of an automatic shutoff has been bandied about for many years. But again, given that the regulators are demanding an islanding capability, maybe engaging it automatically from time to time is not the worst thing that could happen. It increases our security, and the impact on operations is minimal because you've deployed the ability to island already. You've developed the capability of running your OT system independently, and so interrupting that communication for a period of hours at a time while you track things down and say, "Oh, that was a false alarm," I'm guessing is minimal cost. So there's an idea. Let's come back to our topic here. The topic is credibility. We're talking about the risk equation. The typical risk equation is consequence times likelihood. Generally we do it qualitatively, but we wind up with a number coming out of that to compare different kinds of risks. High frequency versus high impact risks. Can you talk about that? Where does credibility fit in that equation?
I think it fits very well into that equation because especially when we talk about the likelihood or the probability part of it, the left side of the equation, it's always a very, very difficult conversation to have when you try to identify the risk or the risk levels we are talking about, or you try to identify the consequence levels involved. It's sad to see that a lot of the conversations, they go astray due to not being able to put a number on the probability or the likelihood. And I think the conversation gets to be much more fruitful if we can get rid of that challenge on trying to figure out the number on the probability or the likelihood. Credibility gives us tools in our language to actually be able to talk about the left part of the equation. So it's something that is a bit more analog, an analog value, where we can move more towards the consequence approach, the consequence driven, where the right side of the equation is more important to talk about, as long as you get, if you consider it being credible, then okay, let's stop the discussion there and focus on identify the consequence levels.
Well, I have to agree. I've argued in my last book that likelihood is flawed. That at the high end of cyber attacks, not the low end. The low end likelihood actually works. The high end, the outcomes of cyber attacks are not random. If the same ransomware hits a factory twice, and all we've done is restore from backup. It took them down the first time. We restore from backup. We make no changes it hits again, they're going to go down the same way. It's not random. I argue that on the high end, nation state targeting is not random either. It's not that they try for a while, and if they don't succeed, they go try somewhere else. Nation state threat actors keep targeting the same target until they achieve their mission objective. It's not random. Once they've targeted you, it's not random. Randomness to me doesn't work at the high end. Credibility makes more sense. Is the threat credible? Is the consequence credible? If this threat comes after us, if this attack comes after us, is it reasonable to believe? Credibility is what's reasonable to believe, not who. What's reasonable to believe? Is it reasonable to believe that the consequence will be realized? I think it makes a lot of sense, but it's new. I don't see the word credibility in a lot of standards. Where does this sit? Is this something people are talking about?
Yeah, absolutely. In my work with the clients I've been working with, and also the professionals I've been working with, we have discussed for some years now that we have discussed the big challenge of the likelihood or the probability part of the equation. And we've without actually without following standards or best practices, we've seen that we need to skip the discussion on the probability or the likelihood and talk about the consequence side of it first, and then we revisit the likelihood and probability afterwards. But I also see in IEC 62443, especially with the 3-2, it actually talks about consequence-only cyber risk analysis. So that's giving opportunity to actually move away from the discussions on probability. And also, of course, with the consequence-driven approach with cyber-informed engineering, we start to see more focus on the far right side with the consequence side, but leaving out what to do with the likelihood. And I think with credibility, we get some language-based tools to actually place it where we talk about it in a qualitative manner instead of having to force it into a number.
I have the sense that over time, in the course of time, cyber attacks become more sophisticated. More sophisticated attacks become credible. Attacks that were dismissed a decade ago as theoretical have actually happened. Do you see that? What do you see coming at us in terms of sophisticated attacks in the near future here?
I think that's a really challenging question. Looking far into the future or far into the history to try to extrapolate what could we expect from the future. We see with Stuxnet, the attacks against Ukraine, Triton, Colonial Pipeline. We see incidents that have had a really high impact, but there's not very many of them. So, but we see it's those kind of capabilities are being explored and are being put into different tools, so they can be used by not only nation states but also criminal groups. So with that kind of analysis, we can expect more and more sophisticated attacks, and also by more and more non-sophisticated groups. So we should expect an increase in high impact incidents.
So if we're not talking likelihood, we're not talking probability, we're talking credible. How do we decide what's credible? How do we decide what's reasonable to believe?
Yeah, that's a good question. So we need to have some grasp of what is credible and what is not credible. I'm also of the opinion that the credibility part of the equation, it's a qualitative thing. It's not a 0 or 1. It's something that is attached to a kind of a slippery slope, not easily defined. But what we could say, if we are trying to see credibility as a 0 or 1, what is credible? Things that have happened, actually have happened once or twice or 3 times, they are credible. So the Triton incident, or a safety-only type of cybersecurity attack, that's now a credible attack because it has happened. And also near misses, that's something that Triton was kind of a near miss. They didn't actually cause a destructive attack, but it could have happened. And so we also have other near misses incidents that we should be considering as credible attacks.
Credibility sounds like a judgment call. How do we decide what's credible?
That's a good question. I think there's good recommendations in 62443, for instance, the 3-2. It talks about, like I said, the consequence only as an example on how you can approach the risk equation. But it also talks about the need for focusing on worst case consequences. So it talks about essential functions, which basically could be the safety functions. For instance, you need to investigate the consequence. If those are actually attacked and compromised, what could be the worst case consequence? So you begin there, and then once you identify the worst case consequences, then you move over to the probability or likelihood dimension. And then you need to consider other factors. So what are the vulnerabilities involved? What are the safeguards? Or what the standard is talking about, your compensating countermeasures. You consider that. You consider the function or the asset as well. That if there's no actual interest in the asset, then the vulnerability could be also non-interesting to address or analyze. So, but you start with the consequence side. Then you start to look at the likelihood and probability, and you are informed by the consequence approach.
Okay, so let me challenge you on that. I've read the CIE implementation guide. It says start with the worst case consequences. It says those words.
Yeah.
I've not seen those words in 3-2. Are you sure that you're not reading into 3-2
No.
what you think ought to be there?
I've been searching for that specific part of 3-2 many times because I've heard others say that the same, and it's actually there. It's really golden nuggets in 3-2, talking about the essential functions, specifically saying the worst case consequence, and also specifically saying that you can choose to do a consequence only risk assessment. So that's really important single words or single sentences in 3-2. So worth highlighting in the 3-2.
Okay, so that makes sense in the abstract. Can you give me some examples? Applying these principles, what should we regard as credible?
Yeah, interesting question. I think the things that come to mind first is, for instance, the Triton incident. Before 2017, when it actually happened, we didn't think it was credible that someone would actually target a safety-only system or cause a safety incident with a cyber attack. With Triton, we actually saw the first of its kind, and the threat became obviously credible. And then SolarWinds as well. It's a very interesting study where the way they actually compromised the SolarWinds update mechanism, suddenly massive deployment of kind of a malware within critical and non-critical infrastructure became a really credible threat as well. And also near misses, of course. We should be informed by things happening out there and coming on the news that are near misses that can talk to us about what is a credible threat. Another kind of near miss that I think, or it's not a near miss, but it's scenarios or incidents that could talk about credibility is where we actually have a safety incident. For instance, we have had lots of them in Norwegian oil and gas and in oil and gas in general, is safety incidents which is not cyber related at all, but where we see that it could be able to be replicated by a cyber attack. So that's something that we should be considering as a credible threat going forward, where we actually could replicate the cyber or the incident with the cyber cause. On credibility, I also think we need to have in the back of our mind, or in the analysis, we have to have focus on the technology evolution, the development and sharing of new technology. So I see it as a graph where we are exposed to more and more heavy machinery or heavy software that can be used on the adversary side. So with Kali Linux, Metasploit, nowadays also AI. So what is becoming a credible threat is more and more sophisticated stuff due to development of technology. So AI now is on both sides of the table, both as an attacker, as a tool that makes more attacks credible, but also on the defensive side, where we actually need to use it to protect against more and more sophisticated attacks.
Let me go just a little bit deeper into Kenneth's last example. I remember talking to him about this 2 days before I recorded this session with Kenneth. I was at another event. I had a half-hour speaking slot. I was, listening politely to the other speakers. I remember, and one of the speakers was a penetration tester. I remember asking the pen tester a question about AI, and his answer alarmed me. And I discussed it with Kenneth. I discussed it with other people since. The future is difficult. I asked the AI, the pen tester. So you touched on AI. What should we look for from AI going forward? And I asked, should we worry about AI crafting phishing attacks? Because I've heard of that happening. Should we worry about AI helping the bad guys write malware to write more sophisticated malware? Because I've heard of that happening. And I paused, and his answer was, Andrew, you're not thinking hard enough about this problem. Yeah, that stuff's happening, but what you need to worry about is somebody taking a Kali Linux ISO image. This is the Linux disk image that everybody uses. All the pen testers use. Lots of attack tools. He says taking that gigabyte of ISO image, coupling it, adding it together with 2 gigabytes of AI model. And the model has not been trained on natural language and creating phishing attacks. The model has been trained by watching professional pen testers attack OT systems, mostly in test beds. I mean, this is what pen testers do. They take a test bed that is a copy of a system that they're supposed to be, doing the pen test on. No one that does the pen test on a live system. They do it on a test bed. They use the Kali Linux tools. They attack the system and demonstrate how you can get into the system and cause it to bring about simulated physical consequences. So you've taught this AI model how to use the Kali Linux tools to attack OT systems, to brick stuff and bring about physical consequences. You take that training model, couple it with the image, wrap it up in enough code to run the image as a sort of kind of embedded virtual machine, to run the AI model, the million by million matrix of numbers that is a neural network. Run the neural network, run the Kali Linux image, and have the AI operate the tools to attack a real OT system. Drop that 3.5 gigabytes of attack code on an OT asset, start it, and walk away. And it will figure out what's there. It will figure out how to attack it. It will figure out how to bring about physical consequences. I heard that and I thought, crap, that's nasty. Back in the day, Stuxnet was autonomous. It did its thing, but it was a massive investment to produce an asset, a piece of malware that did its thing without human intervention. This strikes me as, again, something that will do its thing without human intervention, and it will figure out as it goes. It's one investment you can leverage across hundreds of different kinds of targets. I was alarmed. This is something I'm thinking about going forward. It's, to me, this is a credible threat. This is something we all need to worry about. I don't know that this thing exists yet, but I'm pretty sure it will in 5 years.
Is everything credible? What in your mind is not a credible threat at this point?
I would think that large-scale destructive attacks on big machinery is not something that I would consider a credible attack. But it also goes back to the motivation of the threat actor. For instance, if you have a small municipality, I would see that really heavy, sophisticated cyber attacks, a lot of them wouldn't be actually credible due to the target not being interesting for such a threat actor. So large-scale destructive attacks is something that in a lot of scenarios wouldn't be a credible attack. And then we have, for instance, large-scale blackouts is quite an interesting story nowadays, because a couple of weeks ago I would think that it wasn't actually a credible attack. Once we now see that it can happen, for instance with Spain, it wasn't probably not a cyber attack, but it was something that happened on the consequence side. If we can show that or identify that it actually can be caused by a cyber attack, then that suddenly nowadays, within the last week, has become a credible attack. And also swarm kind of attacks. I hear the discussions on that from time to time, where they talk about whether it's a credible thing where you attack millions of cars. As of now, I don't see that as a credible attack, but things can change.
It's an interesting statement he made there that large-scale attacks on heavy machinery isn't credible. When I think about what we're talking about on this podcast, the purpose of OT security, presumably, is that there are significant risks to really important machines at large scale. But maybe at this point we've covered that?
That's a good point. I think one of the lessons here is that determining what is and is not credible is a judgment call. Okay, different experts are going to disagree. A few years ago, I saw research published saying, look, let's take, for the sake of argument, the possibility of attacking a chemical plant and, causing a toxic discharge. And the researchers concluded that it was theoretically possible, but it was such an enormous amount of effort on the part of the adversary, all of which would have to go on undetected by the site. They said, in the end, I just don't know that this is reasonable to believe that this will ever happen. So, that was one site, one data point. But again, the experts disagree. This is the what I learned on the very first book I wrote. I got wildly different feedback from different internationally recognized experts. Here's an insight. To me, this means that when we make judgments about credibility, we probably have to make, if we're going to make a mistake on the side of caution, err on the side of caution, because different experts have different opinions. We might be wrong. Every expert has to be honest enough to admit that we might be wrong and build a margin for error into their judgment of what's credible. So even if we don't believe that, an attack that, destroys a turbine is credible, we might want to take some reasonable defenses to against, such a not terribly credible attack, in our opinion. But we might want to deploy defenses anyway, just because we might be wrong. And this is something that is also being discussed. It's how big a margin for error do we need to build into our planning. I mean, I talked to a gentleman who produces who designs pedestrian bridges. I said, how do you calculate the maximum load? He says, that's easy, Andrew. You build a barrier into either side of the bridge. Vehicles can't get on the bridge. Most people are less than 2 meters tall. Most people are mostly water. You model 2 meters of water, the width of the bridge, the length of the bridge. That's your maximum load. And then he says, you multiply that by 8, and you build the bridge to carry the multiplied load. Because these are people we're talking about. It is unacceptable for the bridge to fail under load. And so this is the margin for error that engineers routinely build into their safety calculations. I believe, we as experts in cybersecurity need to build a margin for error into our security planning as well.
One of the things that appeals to me very much about the credibility concept is using the concept to communicate with non-technical decision makers like boards of directors. You do this. You have experience with this. Can you talk about your experience?
Yeah, I think it's interesting when we talk to board members and the CXOs in different companies. They don't necessarily go into details about risk, but they know that they have a special accountability. So when we talk about credibility for those kind of people, they are getting more on board with the discussions. They know they have a special accountability. They draw the line in the sand. For instance, if the potential consequence is that somebody would die, then that's a non-acceptable risk. And they take on that kind of position due to their accountability as board members or heads of the company. And they also are being accountable from the government and for the society. So some risks when it comes to the consequence side, if we talk about people dying, then that's absolutely a not acceptable risk for the society. And the representatives for that kind of approach is elected persons in the government, and they put the heads of the company or the board of directors as accountable for that on top of the company.
So that makes sense. Boards care about consequences that the business or the society is going to find unacceptable. You didn't use the word credible. How does credibility fit into acceptability when you're communicating with the board?
Yeah, we don't have to defend against all possible cyber attacks. What we do have to protect against is the credible ones. So when we bring credibility in as a concept, then it's something that communicates much better for the board of directors and the head of the companies.
This has been good, but it's a field big enough that I fear we've missed something. Let me ask you an open question. What should I have asked you here?
We've been talking about credibility. Credibility is what is reasonable to believe. But it's not enough to talk about reasonable attacks. We also need to be talking about reasonable defense. So what is a reasonable defense? We then need to be considering or taking all the tools. We need to use all the tools at our disposal for a reasonable defense. And nowadays, that also obviously includes AI on the defensive side, not only on the offensive side. This is also a very important part of the reason for me joining Omny. So Omny is built on a security knowledge graph. So it's a data model where we can put all information we need about our assets, on the vulnerabilities, on the network topologies, on the threats, the threat actors. So it becomes a digital representation or a digital twin of our assets. Combining that with AI, which we have built in from the beginning, we get a very strong assistant on security where it matters most.
This has been great. Thank you, Kenneth, for joining us. Before I let you go, can I ask you to sum up for our listeners? What should we take away from this episode?
Thank you, Andrew, for having me, and thank you so much for being here in Norway and visiting us at our office. So we've had a good conversation about consequence, the focus on the worst case consequences, where we moved over to talking about credibility, replacing the likelihood concept with credibility, especially for high impact stuff where we don't have the probability or the data to talk about it. We also talked about reasonable attacks and reasonable defenses. So what is a reasonable defense against increasingly credible, sophisticated attacks with high consequences? So it's been a really good discussion about all of these topics. If people want to know more about these topics, or they want to discuss them, please connect with me on LinkedIn and message me there. I'm more than happy to discuss these topics. And please visit our webpage, omnisecurity.com. Our platform addresses most of these topics we talked about today.
Andrew, that just about does it for your conversation with Kenneth Titlestad. Do you have any final words you would like to take out our episode with today?
Yeah, I mean, we've talked about credibility, and this is a concept that is relevant to sort of the high end of sophisticated attacks, the high end of consequence. But I'm not sure. Let me try and give a very simple example. I mean, I was raised in Brooks, Alberta, little town, 10,000 people in the middle of nowhere, literally an hour's drive from any larger population center. In terms of cyber threats, let's pick on, I don't know, the Russian military. Does the Russian military have the money to buy 3 absolute cyber gurus, train them up on water systems, plant them as a sleeper cell in the workforce of the town of Brooks water treatment system, have them sit on their hands for 3 years, and after 3 years, using the passwords they've gained, the trust they've gained, and the expertise that they have them launch a crippling cyber attack that damages equipment, that takes the water treatment system down for 45 days? Is that a credible threat? Well, the Russians have the money to do that. They have the capability to do that. But you have to ask, why would they bother? I mean, this is a little agricultural community. There's a little bit of oil and gas, activity. Why would they bother? That does not seem to be. It does not seem to be reasonable to launch that kind of attack against the town of Brooks. It just makes no sense. I don't see that as a credible threat. Is that a credible threat for the water treatment system in the city of Washington, D.C., home of the Pentagon? I do think that's a credible threat. So the question of what's credible is an important question that I see more and more people asking in risk analysis going forward. We have to figure out what's credible for us. What capabilities do our adversaries have? What kind of assets are we protecting? What kind of defenses do we have deployed? What makes sense? What's reasonable to believe in terms of the bad guys coming after us? This is an important question going forward, and I see lots of people discussing it. And I'm grateful for the chance to explore the concept here with Kenneth.
Well, thanks to Kenneth for exploring this with us, and Andrew, as always, thank you for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.